Hello students, welcome to my class. In this video, we are going to be discussing about the pressure and density concept related questions. Here the first question it was given us, if the pressure at the depth of the lake is equal to 2/3 of the pressure at the bottom of the lake, then what is the depth of the lake they are asking. Here you just imagine a lake. This depth of the lake it was given as, you can assume this the h is the depth of the lake you can take, and here it was given as pressure at a particular depth. Right here at this point, the pressure at a depth, you know the formula, P equals to, will be getting as P naught plus H into rho into G. Will be getting rho is the density of the water and G is the acceleration due to gravity you are taking. Here the question it was given as pressure at half of the depth, means here at this height at half of the depth it was given, which will be equivalent to the 2/3 of the pressure at the bottom it was given. Means here you can take P at half of the depth which will be equivalent to P at 2/3 at a depth it was given. Then here you have to take pressure at a depth formula, you know. So here you can write it as P equals to pressure at half of the depth is P naught plus, instead of H you have to substitute as H by 2 into rho into G, which will be equal to 2/3 of the pressure at the bottom of the lake. So here at the bottom, in the sense here again you have to take 2/3 of the pressure. Here it was given as 2/3 of the pressure at a depth it was given. Means here you can substitute the P naught plus H rho Z. At a depth, you know the formula P naught plus H rho Z, that you have to substitute. So here you have to bring this side 2/3 P naught, you have to bring this side P naught minus 2/3 P naught, which will be equals to 2/3 H rho Z minus this H by 2 rho Z, you have to bring this side H by 2 rho into G will be getting. So when you are taking LCM, here will be getting as 1/3 P naught, which will be equal to, so by taking LCM here we will be getting as 1/6 into H into rho into G you are getting. And again here you have to cancel depth of the lake they are asking. H equals to, you can write it as, you just cross multiply this one, 2 P naught by, you are getting as rho into G. So P naught is an atmospheric pressure, that value approximately I am taking as 10⁵ Pascal, by rho is the density of the water I am taking 10⁵ kg per meter cube, into acceleration due to gravity you can take as 10. You have to cancel 10⁵, 10, 10⁴, and here 10⁴ gets cancelled. 10⁴ will be left over. 2 into 10 will be 20 meters will be getting. So the depth of the lake it was right, H equals to 20 meters. So option second is the right answer. Now we can see the next question. Two bodies are in equilibrium when suspended in water from the arms of the balance. The mass of the body is given as 36 grams and its density is given as 9 gram per cc is given. If the mass of the other is 48 grams, its density in gram per cc they are asking. Here you can take the balance, you can take, here I am just taking assumption. Here this is the balance you can take, and here you are suspending two bodies. This is one body and here this is the second body you have to take. So you are suspending these two bodies in a water. this is the water, you have to take an assumption. And here, what are the forces acting on this body? First you have to take. So here on the first body here, weight of the body, it's going to be acting in downwards. Here the weight of the body will be acting downwards. Let us take an assumption is m1g. And here a buoyancy force is going to be acting in upwards. Here fb1 you can talk. Whereas in the second body here you can take as m2g, it will be acting downwards. And here a buoyancy force is going to be acting here, you can take as upwards, fb2 you can take. Now here the question is given as here the two bodies are in equilibrium, it was given. When the two bodies are in equilibrium, here you have to take the condition as you have to equate the net force values. So bodies are in equilibrium. Bodies are when in equilibrium means here you can take, and the first body here, what are the net force on the first body, which will be equivalent to net force acting on the second body you can take. So net force acting on the first body is m1g, it will act downward direction, and buoyancy force right here it will be acting in upwards. Whereas in the second body, net force acting on the second body is m2g, it will act downwards, minus here buoyancy force is going to be acting in upwards you can take. Now here you can take m1g minus fb in the sense buoyancy force. Buoyancy force formula will be, so density of the liquid into volume of the body, right? Let us take an assumption as v1 and g, rho vg is the formula. And whereas in the second case m2g minus density of the liquid into volume of the second body into g you can take. On both sides here you have to cancel the g value, whereas here you have taken m1 minus rho L into volume of the body, you can write it as mass of the body by m1 by density of the body you can take. Let us take an assumption as d1, first body density I am taken as d1, which will be equivalent to m2 minus density of the liquid into volume of the second body you can take as mass of the second body by density of the second body you can take. Then when you are taking the LCM here, we will be getting as m1 into here you can take 1 minus density of the liquid by density of the first body you can take, which will be equivalent to m2 when you are taking common here will be getting as 1 minus density of the liquid by you can take as density of the second body you can take. Let us take d2 you can take. Then here mass of the first body it is given as 36 gram it was given into, so here 1 minus density of the liquid you are taken as the water density will be 1 gram per cc by here density of the first body it was given as here 9 gram per cc is given, which will be equivalent to m2 mass of the second body is given as 48 grams into 1 minus density of the liquid is water you are taking 1 gram per cc, and we need to calculate the density of the second body we need to calculate. Here you have to simplify these values. Here you are getting as 36 into here 1 minus 1 by 9, it's an 8 by 9 will be getting, it's an 8 by 9 which will be equivalent to 48 into here you can take as 1 minus 1 by d2. So here now you have to cancel this one, so 12 3s 12 4s will be getting, so again here you can take as 4 2s will be getting, and 3 3s will be getting, so here we will be getting as 2 by 3 which will be equivalent to 1 minus 1 by d2 you can take 1 by d2. This is here you can take as 1 by d2 which will be equivalent to 1 minus 2 by 3 you can take, so here it becomes 1 by 3 will be getting. So density of the second body here we have calculated as 3 gram per cc. So 3 gram per cc is the correct answer for this question. Now look at the next question. An inverted bell lying at the bottom of the lake, 47.6 meter deep, has 50 centimeter cube of the air trapped in it. The bell is brought to the surface of the lake. The volume of the trapped air will be, they're asking. So here the lake was given. So here you just imagine a bell, it was given here, an air is stopped inside the bell. Let us take here the volume of the air which is trapped inside the bell will be V1 you can take, and here this is an inverted bell, you have to take an assumption. Next here you can get it as pressure at this point, here you can take as this is P0 plus, so density of the water into G into H you can take. Now the moment when it is coming, the bell is brought to the surface of the lake. Now here you are bringing to the surface of the lake. Let us take here the volume of the trapped air will be, the volume of the trapped air here when you are bringing into the surface, let us take an assumption is V2, and here this pressure you will be getting as atmospheric pressure will be getting as P0 on the surface. So here we can take temperature of the lake, we can take as constant, you have to take here here the question, in the question it was not given, you have to take when pressure and volume related things they are talking, in the sense temperature of the lake you can assume as constant value. Now you know here at constant temperature, so here P is inverse according to the Boyle's law, what you can take, P is inversely proportional to V you are taking, so that here what you can say P1 V1 which will be equal to, you can take as P2 V2 you can take. So initial one, it was the inverted bell is lying at the bottom, and the final values will be on the surface you can talk. Now at the bottom, in the sense here a pressure value you can take as at a depth, what the formula you know, so P0 plus or density of the water into G into H into, you can take as V1. So at the surface, in the sense here you can take as it will be influenced by an atmospheric pressure P0, and the volume, in the sense here you can take as V2 you can take. Now let us take here V2 equals to, you will be getting as V2 which will be equal to P2, you just bring this side, pressure P0 if you are bringing this side, and by taking the LCM here you will be getting as P0 plus density of the water into G into H by, you will be getting as P0 into, you will be getting as V1 you will be getting, and after taking the LCM here we will be getting as V2 which will be equivalent to 1 plus, here we will be getting as rho GH by, you will be getting as P0 you will be getting into, you can take as V1 you can take. Now here you have to put these values, therefore V2 which will be equivalent to 1 plus density of the water value, you know, 10 power 3 kg per meter cube into here, right here you can take as, this is before that you can talk about atmospheric pressure value. Atmospheric pressure value you have to substitute here 1 plus density of the water into G into H by, you will be getting as pressure P0 is an atmospheric pressure you are take as here density of the mercury into G into H you are going to be talking. So here that value you have to substitute density of the mercury into G into H you can take. So here you have to put these values. So first you have to cancel G and G, you have to cancel here V2 which will be equivalent to 1 plus this value, density of the water value is 10 power 3, initially it was given as depth is 47.6 centimeter it was given, by here you will be getting as density of the mercury in the sense here what you can get Here it was given as 70 centimeters, 70 into 10 power minus 2 meter into, so here you can take density of the mercury value is 13.6, 1 gram per cc is 10 power 3 kg per meter cube. H is nothing but, here a height of the barometer column you are taking 13.70 centimeters. Now here you have to substitute these values here, so by cancelling 10 power 3 and 10 power 3, and here 110 you have to cancel here, and here and the next thing is here volume also it was given, initial volume inside the lake it was given as 50 centimeter cube, and here when you are substituting these values V2 which will be equal to 1 plus this is 47.6 by, so 7 into 13.6 into 10 power minus 1, you will be getting as 9.52 you are getting, and again when you are simplifying this value 1 plus 5 and this is 50 also you have to substitute into 50 you have to take, so here 6 into 50 will be getting as 300 centimeter cube you are taking. So 300 centimeter cube is the final answer. And you just look at the next question. A uniformly tapering vessel is filled with a liquid of density it was given as 900 kg per meter cube. The force that acts on the base of the vessel due to the liquid is. So here pressure at a depth formula, here the area it was given as, here the area of the vessel is given as, the bottom is given as 2 into 10 power minus 3 meter square is given, and here this height is given as 0.4 meter, and here you can take pressure at a depth formula, here P equal to P naught plus H into rho into G you are taking. So this pressure is due to the atmosphere you are taking, this is the pressure due to the atmosphere you are taking, and this is due to the liquid you will be getting, due to liquid. Here in the question it was given as, here what they are expecting, here the force that acts on the base of the vessel due to the liquid they are asking, due to the liquid. So here you have to talk due to liquid, the pressure value you can write it as P equal to, you can take it as rho into G into H, you can take rho is nothing but density of the water, don't substitute the density of the mercury, that is due to the atmospheric pressure we will be getting. So P equal to rho into G into H will be getting. Now the question they are asking is force that acts on the base. Pressure formula will be given, force formula on the base which will be equal to pressure into, here you can write as area. So force which will be equal to pressure, here density of the water into G into H into area at the bottom you can take. So density of the water value here, right here, density of the water value is 10 power 3, G you can take as 10, and at this height or depth is given as 0.4 meter into, here area it was given as 2 into 10 power, sorry, density of the liquid density is given, sorry, here liquid density is given as 900 kg per meter cube is given, into G value will be 10 into 10.4 into area it will be taken as 2 into 10 power minus 3 meter square it was given. Then here you have to cancel this value, here are 3 zeros and 10 power minus 3 gets cancelled, 0.4 into 2 will be getting as 0.8, 8 into 9 will be getting as 7.2 Newton you will be getting. So force that acts on the base of the vessel due to the liquid is 7.2 Newtons will be getting. Now just look at the next question. If a siphon is in use is demonstrated in the following figure. The density of the liquid following in the siphon is 1.5 gram per cc. The pressure difference between the point P and as well as S they are asking. Here you can take both the points P and Q. This point P and this point Q, they will be influenced by the atmospheric pressure we will be getting. They will be influenced by the atmospheric pressure. So here pressure at the point the question they're asking is pressure difference they're asking between the points P and S. So pressure at the point P and pressure at the point S, it will be, both will be influenced by the atmospheric pressure is P naught. So they're asking us pressure difference, they're asking pressure difference, which will be equivalent to delta P, or to take here both will be having the equal pressure, which will be P minus P naught minus P naught, we can take as 0. So 3 is the correct answer we will be getting. Now look at the next question. Here the height of the mercury barometer is 75 centimeter at the sea level and 50 centimeter at the top of the hill. The ratio of the density of the mercury to that of the air is given as 10 power 4 it was given, and here the height of the hill they are asking. Here we just imagine a hill. This is at the sea level, you can take. Here it is at the sea level, and here at this point here you can take as pressure will be P1, I am just taking, and here this hill it will be at a height of H height you can take, and here you can take as this it was given as here the ratio of the density of the mercury to that of the air it was given. Height of the barometer is given as 75 centimeter at the sea level is given. Here that means here you can take as P1 equal to density of the mercury into G into H1 is a height you can take. So here the moment when it will be at the top, in the sense P2 equals to density of the mercury into G into H2 you can take. Now the pressure difference between the sea level and top of the hill. First you have to take the pressure difference, between sea level and the top of the hill is delta P you can take here, which will be equivalent to H1 minus H2 into you can take as density of the mercury into G you can take. So here the pressure difference, here a height difference in the barometer will be getting as initial at the lowest point here will be getting as in the mercury here will be getting as 75 centimeter minus when it is at a height H2 here will be getting as 50 it was given into density 10 power minus 2 you can take into density of the mercury. So rho Hg you can take as an assumption into G you can take. Let us take this one as the first equation. So here this pressure difference due to H height is due to the air column you can take. Here let us take pressure difference due to H meter of air column is, so delta P due to the air column, here the pressure difference when you are talking, so H into you can take as density of the air into you can take as G you can take. Now here you can equate both the equations. Let us take here 1 equal to 2 you can take. Here we will be getting as, so H into density of the air into G, which will be equivalent to 2. So 25 into this value will be 25 into 10 power minus 2 into density of the mercury you can take into G you can take. So here you have to cancel the G value on both sides. Here the value is given as H equals to, here it was given as 25 into 10 power minus 2 into density of the mercury by you will be getting as density of the air you will be getting. Here H, now you have to substitute this value, this ratio is given already, therefore H equals here 25 into 10 power minus 2 into this ratio is given as 10 power 4 it was given, and here you have to cancel 10 power minus 2 two times, here we will be getting as 2500 meters will be getting, which is nothing but 2.5 kilometers it was. So it's a 2.5 kilometer. This is the correct answer. Means here pressure difference due to the at the sea level and the bottom level, which will be equivalent to the pressure difference due to the air column you can take. Then you just equate the both the values and you will be getting the height of the hill you will be getting. Now look at the next question. Equal masses of the water and liquid of density 2. Liquid of density 2 are mixed together. Their densities is given. Then the mixture has a density they are asking. So density of the mixture formula for the two liquids will be, the two liquids when you are mixing, so this is m1 plus m2 by density equal to mass by volume you can take. This is a basic formula, mass by volume. When two liquids when you are mixing, here two liquids masses you can take m1 plus m2 by total volume, in the sense v1 plus v2 you can take. Then here which will be equivalent to here m1 plus m2 by volume they are not talking here. In terms of mass and density you have to bring, so m1 by rho 1 plus, here you can get it as m2 by rho 2. Then density of the mixture when you are taking LCM is m1 plus m2 into, here we will be getting as rho 1 rho 2 by, you will be getting as m1 rho 2 plus, here we will be getting as m2 rho 1 will be getting. So here equal masses in the sense, here you can take as m1 equal to m2 you can put. Then density of the mixture direct relation, when you are putting these values, here will be getting as 2 rho 1 rho 2 by, you will be getting as rho 1 plus rho 2 you are getting. Here 2 into water and as well as a liquid density it was given as 2 is given. So density of the water you can take as 1 gram per cc. Density of the other liquid is given as 2 gram per cc, you have to substitute. So here we will be getting as 1 plus 2 will be getting, this value will be getting as density of the mixture will be getting as 4 by 3 you are getting. So second one is the correct answer. Now look at the next question. The volume of an air bubble becomes 3 times as it rises from the bottom of the lake to the surface, assuming atmospheric pressure to be 75 centimeter of Hg and the density of the water will be 1 by 10th of the density of the mercury. The depth of the lake is they're asking. So density of the water, which will be equivalent to, here it was given as density of the mercury by 10 it was given. So here you can take a lake you are taking, here the depth of the lake you can take as h you can take. Here initially the volume of an air bubble will be present at the bottom. Now here bubble becomes 3 times as it rises. So here now it becomes 3 times. So assuming atmospheric pressure to be 75 centimeters of Hg it was given. So here we can talk about its pressure at the bottom, and here let us take as pressure at the bottom will be P0 plus density of the water into G into H you can take, and pressure on the surface you can take as P0 you can take, which will be influenced by the atmosphere. Now here this volume will becomes here 3 times it was given, like this is V2 you can take, and let us take this volume at a depth V1 you can talk. Now here you can take here pressure and volume they are talking. Here you can take depth of the lake H is given, temperature you can take as constant for these kind of questions, right? If the air bubble is going to be rising, then temperature is constant according to the Boyle's law you can take as according to Boyle's law, according to the Boyle's law, P into V which will be equal to constant you are taking. Then here you have to substitute P1 V1 which will be equal to P2 V2, and P1 in the sense initially at a depth, here you will be getting as P0 plus density of the water into G into H into volume. Let us take initial volume will be V. So at the surface in the sense it will be at atmospheric pressure. So volume it becomes 3 times it was given. So here this V you have to cancel. Then P0 plus density of the water into G into H which will be equivalent to 3 into P naught you will be writing. So when you take this side here, 3 P naught minus P naught you will be getting as 2 P naught, which will be equivalent to density of the water into G into H you can take. Now here you have to put this values, height they are asking, or height or depth they are asking. H equals to, you can get it as 2 P naught by, you can get it as density of the water into G you can take. So 2 into atmospheric pressure is given as 75 centimeter of Hg. 75 into, you can get it as 13.6 into G by, here you can take it as 13.6 density of the water value into G you can take. Right, here you can take 13, G and G gets cancelled. Here it was given as right. Here it is, look at here, density of the water it was given as here, density of the mercury by 10 is given. Density of the water which was given as density of the mercury by 10. So this value you will be getting as here, this is 13.6 by 10 you can take, when the density of the mercury when you are substituting by 10 you can take. Here you will be getting as 13.6 and this 13.6 gets cancelled. Here H value will be getting as P naught when you are substituting, be remember density of the mercury into right G into H you can take. Then here we will be getting as 2 into 75 into 10 into right here, these are all the values. Here you will be getting as 75 centimeter it was given, 10 power minus 2 you can take, and here you have to put this value. Then here when you are cancelling this one, here you will be getting as 10 power minus 1, 2 into 75 will be 150, 150 into 10 power minus 1, then H value will be getting as 15 meters you will be getting. So this is the correct answer. Now look at the next question. The value of G at a place decreases by 2%. The barometric height of the mercury they are asking. So here be remember, barometer is an instrument. So barometer is an instrument. Here we are going to be measuring the atmospheric pressure. Atmospheric pressure we can calculate. So P naught atmospheric pressure formula will be H into rho into G, H into density of the mercury into G you are taking, which means here atmospheric pressure is constant value. Here you can get it as G values decreases by 2%, then the barometric height of the mercury they are asking. Then we have to bring the relation between G and as well as H value. Then H is inversely proportional to, here we will be getting as G will be getting. Here the question it was given as G decreases by 2% means obviously here it's a decreased value, then here H value is going to be increases by 2% will be getting. So H can increases by 2%. So first one is the correct answer. Now look at the next question. A barometer kept in a stationary elevator reads 76 centimeter. If the elevator starts accelerating up, the reading will be they're asking. Here you are taking it's an elevator you can take. Inside an elevator you are keeping the barometer. Here you can take barometer you are keeping. Here this is the mercury you can assume, and here this is the barometer you are keeping like this. Now the level of the mercury it's going to be increases like this. Initially when it is at the stationary left, here it is showing as 76 centimeter of Hg showing. 76 centimeters of Hg showing when it is at the rest. Now the lift is accelerating, the elevator is going to be accelerating up with an acceleration gauge. Now pressure atmospheric pressure due to the barometer is P naught equal to H into density of the mercury into G, you can take. H is inversely proportional to, you'll be getting as P by P naught by rho into G, you can take. That doesn't mean, that is here H is inversely proportional to 1 by G, you can take. H equal to, you can take, this is H equal to P naught by rho G, that is H is inversely proportional to G, you can take. Means if the lift is accelerating up in the sense, here you can take, if the lift moves upwards, moves upwards, then G effective value you can get it as G plus A will be getting. Means effective G value it's going to be increases, that is G increasing. So G increasing in the sense here, if G is an increased value, height of the mercury column it's a decreased value will be getting. Initially when it was at the stationary, it is showing as 76 centimeter. When the lift is accelerating up, then effective G value is increasing. Effective G value is increasing in the sense height of the mercury column in the barometer is going to be decreased value. So the answer it was given as H should be a decreased value. So it is showing as less than 76 centimeter, it will show us. Now here the question it was given as a vertical U-tube. The next question, a vertical U-tube of uniform inner cross section contains a mercury in both the sides of its arms. A glycerin density is given as 1.3 gram per cc column, and here oil density is given as 0.8 gram per cc, and here is poured into the other arm until the upper surfaces of the oil and glycerin are in the same horizontal level. Find the length of the oil column they are asking. So here you are pouring a glycerin wood. It was placed in the U-shaped tube. It was at 10 centimeter height. Now you are pouring some oil. So both the liquids columns, here height of the oil it was showing as H, then here glycerin it was given as at 10 centimeter it was given. Now here you can take, here we need to calculate the length of the oil column, how much it is. Now here let us take an assumption. Initially this was glycerin, and here this height it's given as up to 10 centimeter you are filling. Let us take this point will be A, and here at the same level you can assume as this is a B point you can take, and here it was given as this right, this liquid will be the mercury is given, and here they are at the equal heights in the sense this is at 10 centimeters and oil will be H in the sense here, and this height it will be obviously will be getting as 10 minus H will be getting, this height will be 10 minus H from here to here. Means here this side on the right side here you will be getting as at the B point, so up to 10 minus H level here it was filled with the mercury, the remaining it was filled with the oil. Now here liquid is rest you can take on both the limbs. So at equilibrium what we can say, at equilibrium you can take pressure at the point A which will be equal to pressure at the point you can take pressure at the heights, pressure at the equal heights it will be same according to the Pascal law. Pressure at the point A in the sense P equal to H into rho into G or T. H is nothing but so 10 centimeter into density of the glycerin it was given as 1.3 into G you can substitute, which will be equivalent to pressure at the point B. So at the point B you will be having the two liquids, one is the mercury and second one is oil. First let us talk about the oil you can talk. Oil density it was given as 0.8 into that height it was given as H into G you can take plus, now you can talk about pressure at the mercury due to this mercury. H in the sense we have to substitute as 10 minus H into density 13.6 into G you have to substitute. On both the sides we have to eliminate the G value. Here we will be getting, and this side 10 into 1.3 will be getting as 13, which will be equivalent to 0.8 H plus 10 minus H into will be getting as 13.6 will be getting. So here you have to simplify this value. This is 0.8 H plus, so 10 into 13.6 will be getting as 136 minus 13.6 you are getting, and this is 13, and here you have to bring this side. So 0.8 this is 0 minus 13.6 H. So 0.8 H minus 13.6 H will be getting as minus 12.8. Here you have to bring this side. Here this becomes 12.8 H, which will be equal to 136 minus 13, which will be 123 will be getting. Therefore H equals to, here you can take as 123 by, here we will be getting as 12.8. So when you are substituting this value, it's nearly will be getting as 9.6 centimeters will be getting. So height of the oil, it will be length of the oil column, or find the height of the oil column. H value will be getting as 9.6 centimeters, an exact value. Here it's a closed value, it's given as 9.7 centimeters. So this will be the answer. Next, look at the next question. So with the rise in temperature, density of the given body changes occurring according to one of the following relations. So here, when temperature is increasing, density of the liquid is going to be decreases. Then density at a particular temperature by density at a 0 degree Celsius, which will be equivalent to. So density at a particular temperature is here mass by its volume by, you can take as mass by its initial volume, you can take as V0. Mass remains same, will be getting when temperature is increasing. So this is V0 by, you will be getting as volume at a particular temperature you are getting. So rho by rho naught, this is density at a particular temperature, and density at 0 degree Celsius you can take. It's V0 by V at a particular temperature according to the volumic expansion of the gases. Gamma equal to, you can write it as delta V by V into delta T will be getting. With this, the final volume you will be getting as V equals to V0 into 1 plus gamma into delta T. You learnt already this concept. Instead of V0, V, you have to put the value. Volume at a particular temperature is V0 into 1 plus gamma into delta T. You have to substitute. V0 gets cancelled. Rho by rho naught, which will be equal to 1 plus gamma into delta T whole power minus 1 we can get. So it is in the form of binomial expansion. So 1 plus x whole power n, which is approximately will be taken as 1 plus nx. So this is for x is much less than 1, right? This is a binomial expansion will be calling. So rho by rho naught, which will be equal to 1 minus, instead of here 1 plus nx, n value will be getting as minus 1 minus gamma into delta T. How to substitute? So density at a particular temperature, rho equal to, you can write it as rho naught into 1 minus gamma into delta T, you can substitute. So this will be the correct answer. Rho equal to rho naught into 1 minus gamma into delta T are getting. Now look at the next question. 3 liquids of densities it was given as D, 2D, 3D are mixed in the equal volumes. Then the density of the mixture they are asking. When 3 liquids, when you are mixing, density, the formula will be density equals to mass by volume. Then density of the mixture, when you are talking 3 liquids, when you are mixing, here you can take as its proportions will be m1 plus m2 plus m3 by its volumes, you can take as v1 plus v2 plus v3 you can talk. Now masses they have not given, densities and volumes they are talking here. Instead of mass, you can take as volume into density. So volume into, they have given as equal volumes, it was given volume into initial density will be D plus volume into second density is given as 2D plus volume into third density is given as 3D by equal volumes V plus V plus V. Here we can take as 3V, VV gets cancelled. So here it will be 6d by 3 you will be getting. So density of the mixture you will be getting as 2d you are getting. So this will be the correct answer. Now look at the next question. Radius of an air bubble at the bottom of the lake is given as r is given. It becomes 2r when the air bubble rises to the top surface of the lake. If p centimeters of the water to be the atmospheric pressure, then the depth of the lake they are asking. Here you can take here it was given a lake is given, this depth is given as depth you have to take an assumption is h. Initially the air bubble will be present at the bottom, right? It's a radius it was given as r it's given, and it becomes 2r when it coming to the surface, rises to the top surface. P centimeter of water will be the, it's an important, P centimeter of water will be the atmospheric pressure they are given, then the depth of the lake they are asking. Here you can take pressure at the bottom, you can take as right, P naught plus density of the water into G into H you can take. On the surface here this pressure will be P naught you can take. Its volume you can take as V1 you can take, and final volume you can take as V2 you can take. Here you can take pressure and volume relations here, right? Here what you can take, temperature you can take as constant according to the Boyle's law. So here you will be writing as P1 V1 which will be equal to P2 V2 you can take. Initially it was given as initial radius at the bottom will be R1 equal to R you can take. The moment when it comes to the surface, its radius it becomes twice it was given, 2 times of the R you can take. Now here you have to put this values P1 V1 in the sense initial pressure at the bottom will be P0 plus H into density of the water into G you can take, into volume will be volume of the spherical bubble will be 4/3 pi r cube you are getting, which will be equivalent to 2. So pressure at the surface will be P0 into volume at the surface will be 4/3 pi into, so here you can take as 2r whole cube, it's nothing but 8r cube you are getting. This r cube gets cancelled, and 4/3 pi are to cancel. Then so atmospheric pressure it was given as, atmospheric pressure is given as P centimeters it was given. General formula will be getting as P0 equal to H into rho into G it was. So instead of H they have mentioned as P centimeters it was given. So P into, so let us take density value here you can take as it's rho W into you can take as G you can take, plus this value will be H into density of the water into G you can take, which will be equivalent to P0 is an atmospheric pressure. Then again you have to substitute as atmospheric pressure is given as P centimeters of the height, P into density of the water into you can take as G you can take, into it was 8 you can take. So here also atmospheric pressure, don't substitute the value of right, the mercury don't substitute. Here it was given as water is given, means inside the barometer will be having the water, so that water density you need to substitute. So here you have to cancel, this is here the G you have to cancel on both sides, density of the water also you have to cancel on both sides. Here this is also some, this is here will be getting as P will be getting, this is H, here you can get it as H which will be equal to, here this is 8P minus this side will be getting as P you will be getting, then H value will be getting as 8P minus P you will be getting as 7P is the correct answer. Now look at the next question. When equal volumes of the liquid are mixed, the specific gravity it was given as here 7/2 is given. When the equal masses of the same liquids are mixed, the specific gravity is 12/7. The specific gravity is of the two liquids they are asking. So for equal volumes You be remember density of the mixture formula will be, here it's a rho 1 plus rho 2 by 2. This is the formula for equal volumes. So the specific gravity of the mixture. Specific gravity formula will be density of the substance by density of the water. Then here density of the mixture, specific gravity of the mixture itself is given as 7 by 2. So here you can take this value, you can take as 7 by 2, then 2 gets cancelled. Then here we will be getting as rho 1 plus rho 2, you will be getting as 7 you will be getting. Let us take here, this is the first equation. Whereas in the second case is here, for equal masses when you are mixing, for equal masses, the density of the mixture formula will be getting as 2 rho 1 rho 2 by rho 1 plus rho 2. When mix equal masses when you are mixing, the specific gravity of the mixture is given as 12 by 7. So specific gravity of the mixture which will be equivalent to, here you can take as 12 by 7 we can take here, which will be equivalent to 2 rho 1 rho 2 by rho 1 plus rho 2, it is 7 you can take. Then here 7 gets cancelled, 2 6 times it was going. Then rho 1 into rho 2 which will be equal to 6 you are getting. Then rho 1 rho 2 values you know, and rho 1 plus rho 2 you know, you just substitute right first and second equations. So rho 1 minus rho 2, a minus b whole square, the formula will be a plus b whole square minus 4ab will be getting. Rho 1 plus rho 2 value you know already, 7 whole square minus 4 into 6 you have to substitute. It's a 49 minus 24, you will be getting as 25 you are getting. So it's a rho 1 minus rho 2 whole square is 25. Then rho 1 minus rho 2 value will be getting as 5 you are getting. So with this here you know the values, rho 1 plus rho 2 equal to 7, rho 1 minus rho 2 value will be 5. You have to simplify this one by adding these two values. 2 rho 1 which will be equal to 12 you are getting, then rho 1 equal to 6, and obviously rho 2 value will be getting as 2 will be getting. So here the specific gravities of two liquids. Specific gravities of the two liquids doesn't mean specific gravity equal to density of the substance by density of the water. So here when you are taking specific gravity, the values will be rho 1 rho 2. Specific gravity, the formula will be density of the first one by density of the water. Then rho 1 equal to specific gravity value, which will be equivalent to 1 gram per cc, 1 gram per cc you have to take. Then specific gravity of the first value will be getting as 6. Specific gravity of the second value also will be getting as 2 will be getting. So this is the answer. Now look at the next question. Here 3 liquids of densities D, 2D, 3D are mixed in the equal proportions. Here equal proportions. Equal proportions doesn't mean here masses are equal, you can take equal proportions. Means here equal masses you are mixing. Masses are equal. When you are mixing, here the relative density of the mixture they are asking. So first you have to calculate the density of the mixture will be when 3 liquids when you are mixing. This is m1 plus m2 plus m3 by, you can write it as v1 plus v2 plus v3. So equal masses in the sense m plus m plus m you will be getting as 3m you will be getting. Volume in the sense you can take as mass by density. So here the density will be D. Second density it was given as 2D, and third density it was given as 3D. So m, by taking the common in the denominator, so m you have to remove. Then the density of the mixture value will be getting as 3 into, by taking LCM here it will coming to the numerator 6D by, you will be getting as, so by taking LCM here will be getting as 11 you will be getting. So here will be getting as, it's an 18D by 11 will be the density of the mixture. Relative density of the mixture. Relative density of the mixture doesn't mean here we can take as, so density of the mixture by density of the mixture by density of the water you can take. Then density of the water value will be getting as 1 gram per cc. Then obviously will be getting as 18d by 11 you are getting. So 18d by 11 is the correct answer you are getting. Look at the next question. If the air density were uniform, then the height of the atmosphere above the sea level to produce a normal atmospheric pressure is 1.0 into 10 power 5 pascal they're asking. So normal atmosphere at the sea level they're asking. Sea level to produce the normal atmospheric pressure. Means here air density it was given as uniform is given. Suppose let us take here this is an earth you can take. Somewhere here you can take this is the sea level you have to take on the surface of that, and here up to certain height the air density it was given as uniform is given. Means here at the density of the air it will be rho, in the sense here at a height also will be getting as a density of the air it will be rho you are getting. So pressure at the sea level due to the air, in the sense here will be getting as at the sea level, which will be equal to h into rho into z will be getting. Rho is nothing but you can take as density of the air you can take into g into h you have to take. So here h is which will be equivalent to pressure at the sea level by here we will be getting as density of the air into you can take as z you can take. Therefore h equals will be getting as pressure at the sea level is given as pressure at the sea level to produce a normal atmospheric pressure, right? Here it was given as already 1.0 into 10 power 5. Density of the air it was given as uniform, that value is given as 1.3 kg per meter cube. 1.3 into you can take as 10 you have to take 10 power 4, and here it will be you can take as 1.3 you can take as 13 by 10, then it becomes 10 by 13 into 10 power 4 you have to substitute. Therefore h value you can get it as nearly 0.769 into 10 power 4 will be getting. It's close to h value will be getting as 7.7 kilometers you are getting. 7.7 kilometer. So up to this height the density will be uniform. So this will be the correct answer. Now look at the next question. The pressure at the bottom of the lake due to the water is given as 4.9 into 10 power 6 Newton per meter square. What's the depth of the lake they are asking? Here you can take, this is a lake you have to take. Here this depth of the lake you can take an assumption is h, and here pressure at the depth you know the formula P equals will be getting as P due to the atmosphere plus pressure due to the water. So here you can take as pressure due to the water is P equal to rho into G into H you can take. Now the question is here, what is the depth of the lake? The pressure at the bottom of the lake due to water. So pressure at the depth is P naught plus this is the pressure due to the water. This is the pressure due to the water you can get. So pressure due to the water, the formula will be getting as H into rho into G will be getting. Rho is nothing but density of the water. Therefore H which will be equivalent to already this pressure value is given for the water. H equal to you can take as pressure due to the water by you can take as rho into G you can take. Here it was given as 4.9 into 10 power 6 by rho, in the sense density of the water value is 10 power 3 into you can substitute 9.8, and here 2 times, here the 10 power 3 and here 10 power 3 gets cancelled, 1000 by 2. Therefore h value will be getting as 500 meters you are getting. So this is the correct answer. Now look at the next question. It was given as if the atmospheric pressure is 76 centimeters of Hg, at what depth of the water in the lake the pressure will become 2 atmospheres nearly. Pressure at a depth formula P equal to P naught plus H into density of the water into G you can take. here it was given as pressure at a depth. It becomes 2 atmospheric pressure at a depth. This is the pressure at a depth formula. At a depth here it was given as 2 atmosphere, and let us take this is P naught equals, you can take as 1 atmosphere, you can take, and plus H into rho into G, you can take. So here you can take as 2 minus 1 is 1, you can get, then H value will be getting as, it's a 1 atmosphere by, you can get it as density of the water into G, you can take. So you know 1 atmospheric value, 1 atmosphere value will be 1.013 into 10 power 5 pascal by density of the water value will be 10 power 3 into G value, you can take as 9.8, you have to take. And here 10 power 3 and here 10 power 3 gets cancelled. Here we will be getting as H value, you can get it as 101.3 by, you can get it as 9.8. So this value nearly will be getting as 10.33 meters you are getting. So here they are asking in centimeters, then 1 meter equal to 100 centimeter you have to take. So here we will be getting as 1033 centimeter we will be getting. This is the depth of the lake. So this will be the correct answer. Next, look at the next question. An airtight containing container having a lid with the negligible mass and an area is given as 8 centimeters, it was given, partially evacuated. If 48 newtons force is required to pull the lid. So here you are taking a lid, you are taking to the container, and this is a container you can take, right? Here you are getting as, here you are trying to open the lid, so with the 48 newtons force. So here you are applying the force along this direction to open the lid, and here this is here two things you be remember. One here one force due to the atmospheric pressure will be getting as pressure due to the atmosphere. Pressure due to the atmosphere, it will experience the force along this direction. So force due to the atmosphere is pressure due to the atmosphere into area you can take, and here pressure due to the container. Pressure due to the container you can take as, here it will be acting along this direction. So pressure due to the container is the inward pressure you can take into A you can take. This is a force value, and here you are applying the force to remove the lid. Now here you just equate these values. Atmospheric pressure value, here you will be getting it is in downwards. The force values I am just talking. So P naught is an atmospheric pressure into A, which will be equivalent to these two forces you have to take. So pressure due to the container is P inside you can take, pressure in the container they are asking. This is, let us take as PC you can take, into A. Area will be same, on the same lead it will be experiences the pressure plus some force value you are going to be applying. So here you can talk about the pressure due to the container into A, which will be equal to P naught A minus F you can take. Then pressure due to the container, which will be equal to P naught minus F by A you can take. So therefore PC, pressure due to the container, is P naught value will be the atmospheric pressure. It was given as 10 power 5, and you are applying the force value is 48 newtons by area of the lid is given as here 8 centimeter square. 8 into centimeter square you have to convert 10 power minus 4 meter square, and here 860. So here you have to take as 10 power 5 minus, so this value will be getting as 6 into 10 power 4, and that I am making as 0.6 into 10 power 5. Here you can get it as pressure due to the container is here 10 power 5, when you are taking common here 1 minus 0.6 you are getting, 1 minus 0.6 will be 0.4. So here pressure due to the container is 0.4 into 10 power 5. On 10 power 5 you have to treat it as atmosphere. So pressure due to the container will be getting as 0.4 atmosphere you are getting. Now look at the next question. Here it was given as a beaker containing a liquid of density is given as, here in the options it was given as rho is the density. Here you can take the density will be rho. It moves up with an acceleration a. The pressure due to the liquid at the depth h below the surface of the liquid is. So here if the lift is accelerating up, the lift moves up with an acceleration a, then the g effective value will be getting as, g effective value you can get it as g plus a will be getting. So pressure at a depth, h due to the liquid, generally the formula will be getting as due to the liquid, in the sense here rho into g into h into rho into g, you can take g effective value you have to substitute when it is moving up here with an acceleration. Then g effective value here h into rho into, you can get it as g plus a will be getting. So this is the h into rho into g plus a will be the correct answer. Below the free surface of the liquid will be. So this will be the correct answer. So thank you for watching.